magnetic field on the axis of circular current loop. Okay, now just understand the concept of this. See what is happening in this is a wire, and in this wire current I is flowing. Okay, current I is flowing. When current is flowing, we know that because of the motion of the current, because the motion of charges, there will be production of magnetic field. Okay, so this at distance r, we are considering that there will be a magnetic field. There will be some magnetic field. Okay, so that magnetic field, for that magnetic field, I am just see this is, let us consider this is angle phi. This is dB. dB means what will be this, the angle between them, that angle between this r and dB, that will be 90 minus r, because this entire is 90 degree. So you can write here, I will just zoom this thing. Okay, so this will be 90 minus 5. Okay, once more. Yes, let's see it once more. Yes, check. Current is flowing in this wire. Current is flowing in this wire. At distance r, there will be a magnetic field. Okay, this magnetic field. See, this magnetic field dB can be resolved into two components. This perpendicular, what we can name this perpendicular? This perpendicular can be named as dB. Yes, that's perpendicular. This is theta. See, if I will say this is phi, this will be 90 minus 5, right? Because this is entire 90 degree, you can write it as 90 minus 5. So what will be this? This will be, yes, this entire is 90 degree. So 90 minus 90 minus 5, 90 minus 90 minus 5. So this will be what? This will be 5. In place of phi, wherever there is an angle, what you will write? You will write dB cos phi, and when there is no angle, you will write here as dB sin phi. At angle at x distance, magnetic field is produced. From here, it is R. Okay. Now, what you are supposed to find? You are supposed to find how much magnetic field is produced. Okay. So I will give you the derivation for this. Yes. First of all, that net magnetic field will be integration of dB sin theta. And what is dB? dB, what is dB? What is dB? dB is your mu naught IDL sin theta, that means sin 90 over 4 pi r square. And what is sin 90? Sin 90 is 0. So therefore you will write your dB will be equal to integration of, in place of dB, your B net will be equal to, not dB, your B net will be equal to mu naught IDL upon what? 4 pi r square. Okay, you can write 4 pi r square. Now net will be, now if you're talking about the net can be because of any angle, so you can write here sin phi. So this will be equal to what? This will be equal to integration of mu naught into IDL upon 4 pi r square. In place of sine phi, you will write r upon r. So this will be equal to what? This will be equal to integration of mu naught I dl into r upon 4 pi r cube. Okay, 4 pi r cube. Now, but in place of r cube, we can write, see, this is a triangle. This is a triangle. Short and sweet. Yes, this is a triangle. In this triangle, this is hypotenuse, this is capital R, here it is capital R, here we have capital R. Yes, it got hidden by because of my line, and here it is X, here it is R. So we know the formula for hypotenuse. Hypotenuse is equal to under root of R square plus X square. So in place of R square, can I write under root of capital R square plus X square? Yes, we can write that. So here you can write it as is equal to integration of mu naught I dl into R over 4 pi. In place of R, you can write R square plus X square raised to 1 upon 2. Yes. And already we have 3 here. So here we can write R plus X square raised to 3 upon 2. Okay. Here you can write R square plus X square raised to 3 upon 2. So anything constant here? Yes, we have something constant. We have mu naught constant, we have I constant, we have R constant, we have 4 constant, we have pi constant, we have R square constant, we have X square constant, we have 3 raised to 2 constant. And what is not constant here? The not constant is non-constant thing is integration of dl. This is a circular path. So what will be dl? Yes, dl will be the circumference. So what is circumference? Circumference will be, yes, I'm writing the values again, 4 pi r square plus x square raised to 3 upon 2 into, what is integration of dl? Integration of dl will be 2 pi r. So pi and pi will get cancelled, 2 ones and 2 twos are. Okay, and this r will become r square. So your modified formula for v net will be equal to what? Your modified formula for v net will be equal to mu naught I r square upon me, what you have, upon me you have, what you will write here? You will write here mu naught I r square over, yes, 2 r square plus x square raised to 3 upon 2. What is this? This is your net b net formula. This is your b net formula. This is your b net formula. Now my question is, if you have b net formula, where's the formula? You got the b net formula like this. Sorry, you got b net formula like this. What will be the value at center of loop? At center of loop, you will keep x 0. You will keep x 0. When your x will be 0, so that will be what? B naught will be equal to mu naught I r square upon 2 r cube. This square and this 2 will get cancelled. So what you will get here, you can also cancel square and cube, 2 and 3. So you will get what? You will get mu naught I upon 2r. Mu naught I upon 2r. Okay. Yes. So this is how you can find magnetic field on the axis of circular current carrying loop.